Hey there, electrical enthusiasts. Welcome back to The Battery Man. I'm Andrew, and I'm thrilled to have you with me on my journey into what it takes to become a qualified electrician. This week, we're diving into the amazing realm of electrical testing and inspection. For those of you inspiring to become electricians, this knowledge will give you the confidence to tackle the challenges ahead. And for all you curious minds out there, get ready to uncover mysteries of what electricians learn and know. So without further ado, let's kickstart week 2. The next section for this week is earth continuity. This covers earthing and bonding. Well, hopefully we know that earthing is the current path back to the source in the event of a fault. This earth path is provided to all circuits and protects devices and metal light switches and sockets and so on. What about any exposed metal pipework in a house or building? This is where equipotential bonding comes in. Nailed it. The extraneous conductive parts such as gas, water and oil pipes are all connected back to the main earth terminal of the property. This avoids a potential difference or voltage potentially between you and the metal pipework. This also helps to avoid something which I learned about called corrosion current, which can cause the metal pipework to corrode away. Where these bonding conductors meet pipework, they'll have a label saying safety electrical connection. Have you spotted these before? I know some of you might be pausing this video now and running around your house to look for them. Then there's supplementary bonding. If metal pipework has been interrupted by plastic pipework, which is becoming more and more common with plastic pipework being easier to work with and, shall we say, more DIY friendly, supplementary bonding connects the two metal parts together. This is particularly for locations containing a bath or a shower. As a former DIYer, other than voltage testing, I wasn't really familiar with any of these tests that we're going to cover next. I hadn't heard of R1, R2. I didn't have a clue what they meant. Once a system has been isolated and tested to ensure it's dead, an inspection and testing procedure can be carried out. There are a number of tests for a dead system, and there's some for a live system. Those for a dead system are testing for mains voltage, ensuring that there isn't any voltage, the continuity of the CPC or earth, the continuity of the ring final circuit conductors, insulation resistance and polarity. The voltage test ensures that you're not going to die by carrying out the following tests. The continuity test ensures that all the circuits don't have any breaks and that they have a sufficiently low resistance or path for the current to be able to take. The insulation resistance test ensures that the insulation is working as it should and preventing current leaks between live and earth and live conductors in a three-phase system. The polarity test ensures that the line and neutral are the correct way around, ensuring that the protective devices and switches are on the line only. All of these tests require a visual inspection first, with a number of different requirements such as no damage to accessories, equipment and cables, and all that the terminals are mechanically and electrically sound, including ensuring that safety devices are correctly rated. Testing of the continuity of the CPC ensures that if there was a fault situation, the current path can flow safely to earth and operate the circuit protective device. There are two methods for testing. The first is by putting a temporary link between the ring line conductor or wire to the earth block in the consumer unit. Then at the furthest point, such as say a ceiling light, we'd then use a test meter and test between the earth and the live. This gives us the value of R1 and R2. R1 being the line conductor and R2 being the CPC. Then, by moving the link in the consumer unit between the main ring and the neutral and carrying out the same test, but with the two leads in the sealing rows between the line and neutral, you've got the R1 and Rn. R1 being the resistance of the line conductor and Rn being the resistance of the neutral conductor, with both the line and neutral being the same size conductor and roughly the same length, they should have the same resistance. So dividing them by 2 will give R1, or the line resistance, or half the path that we just tested. This then means that if we take the figure that we just got for R1 away from the first reading of R1 plus R2, then you'll be left with R2, the earth resistance. Clever, hey? A reading below 1 ohm should be expected for this test. The second method is to get the R2 by using what's called a long wandering lead, which effectively means that you can connect the test meter to the earth at the furthest sealing rows using a long lead to go back to the consumer unit earth connection. This just requires that the resistance of the probes and leads is first measured, recorded and removed from the total resistance value. Testing the continuity of the ring final circuits ensures that there are no breaks in any ring circuit conductors and proves that there are no cross connections between sockets and outlets. Under normal circumstances, each socket terminal would be supplied with 2 conductors. As an example of why this is important, a 2.5mm squared PVC cable has a current carrying capacity of 27 amps. But as a socket is supplied by 2 of these in a ring, it effectively makes it a 5mm squared cable with a current carrying capacity of 54 amps. A ring circuit is usually protected by means of a 30 or 32 amp protective device. So if a break was to occur, it effectively makes 2 radial circuits with a carrying capacity of only 27 amps. With a protective device that's greater than its capacity, this could potentially cause damage or a fire as the cables are overrated and the protective device wouldn't operate. So how do we do this test? Well, we'd have 2 sets of cables in a ring main at the consumer unit. So, first of all, the resistance would be measured using a low resistance ohm meter between both the line conductors, then both the neutral conductors, and finally both CPC conductors. According to my information, the line and neutral loop should be within 0.05 ohms of each other. Higher than this suggests something isn't right. However, because the CPC is a smaller cable, its resistance would be slightly different. The next step is to create a connection between one of the neutrals and one of the lines, and do the same for the other pair. You would then test at this point in every socket on the ring. The reading should be about the same at each outlet and approximately a quarter of those for the line and neutral loop. The next step is to cross over the line and earths instead of the neutrals. Again, the reading should be approximately the same at each outlet and a quarter of those tested at the consumer unit end. This measurement between line and earth results in R1 and R2 values. Next, the test of the insulation resistance is conducted to verify the basic protection by determining the condition of the insulation around the conductors. This is done with an insulation resistance tester. The voltage of this test depends on the usual voltage for that circuit. It requires appliances to be unplugged, lamps to be removed, circuit breakers to be disconnected, and so on. First, the test is carried out between the line and neutral conductors and the readings are recorded for each circuit. The same test is carried out between the line and earth conductors. Finally, between the neutral and earth conductors. It's worth pointing out that although these tests are on a dead consumer unit and circuits, the test provides a fairly high voltage 500 volt DC from the test device when testing main circuits. So don't go licking the probes, alright? I know it won't be as strong a hit, but in my head I'm kind of imagining a defibrillator. Well, congratulations on making it through week 2. We've delved deep into the world of electrical testing and inspection. Whether you're on your path to becoming an electrician or simply seeking electrifying knowledge, I hope you found this week's journey enlightening. Next week we'll be shining a spotlight on health and safety, addressing the risks associated with electric shocks and more. If you found this video informative and enjoyable, be sure to like and subscribe the channel for more electrifying content. I might have read ahead, so I promise it does get a little bit more exciting than health and safety. Feel free to leave a comment or questions below. I'm here to help you on your journey to understanding electricity better. Until next time, stay curious and keep exploring. See you in week 3.